we're starting chapter 6, and the first section, 6.1, is on solving quadratic equations by factoring. Alright, so what we have here, y equals x squared minus 2x minus 3, this is a quadratic function. And we've been dealing with that in the last chapter, chapter 5. You remember we graphed these, for instance. And in fact, let's do that right now. I want to graph this because it's going to help us make a connection with quadratic equations and quadratic functions. So if we're going to graph this, this is in general form. So you wouldn't be able to tell the vertex right away. You could complete the square with this, or you could use our favorite, the negative b over 2a. Why don't we do that? So to get the x value, we need to do negative b over 2a. So that's negative, the b value is negative 2 over 2, the a value is 1. So we get negative negative 2, which is just 2, and 2 times 1 is 2, so we get 1 as our x value. Now to get our y value, you could use that other crazy formula, which I don't remember, or you could plug 1 into all the x's. So we get 1 squared minus 2 times 1 minus 3. That equals 1, take away 2, take away 3, which equals negative 4. So our vertex is at 1, negative 4. And I guess I could write that. Vertex is at 1, negative 4. Does this thing face up or down? Well, it has an a value of 1, positive 1, so it faces up. And an a value of 1, that's great. It's congruent to the mother function. So I can use step pattern if you know how to use it. We go over 1 and up 1, over 1 and up 3, over 1 and up 5, and over 1 up 7 will be off the grid. So we'll stop there. And then by symmetry, we can do this. And I'm hoping you're kind of looking impatiently at this video and saying, we already know all this. Why is he doing this? But just give me a second. Okay, that's terrible. But anyway, you get the idea. Now, the most important part of the graph for today, since we're going to start talking about quadratic equations, is the x-intercepts. So where are the x-intercepts? It's where the parabola crosses the x-axis. So there's one x-intercept here, and there's one x-intercept there, right? So I'm just going to actually write that down, that the x-intercepts are at, so where are they? This one's at negative 1, 0, and the other one is at 3, 0. Nice. Now, having done all that, we can finally make the connection between quadratic functions, which we've already talked about, and quadratic equations, which this chapter is all about. Basically, they're very, very similar. The only difference is, with a quadratic equation, you see this y equals x squared minus 2x minus 3? Here's an example of a quadratic equation. X squared minus 2x minus 3, it's exactly the same as this, but instead of making it equal to y, I make it equal to 0. This is really the only difference between a quadratic function and a quadratic equation. A quadratic equation is equal to 0, and then you're trying to solve that. You're trying to find what are the value or values of x that you could plug in here and here to make the left-hand side equal to 0. Okay, now how does this relate to the parabola here? Well, if you think of it for a second, these x-intercepts right here, what's the y value of every single point on the x-axis? All these points along here. We've talked about this a whole bunch of times. If you're looking for the x-intercept, you make the y value 0. Oh, so if I was to make this y value 0 and solve, I would get the x-intercepts. But what I've done when I put that 0 in there is I've made it into a quadratic equation. So this is the relationship between quadratic functions and quadratic equations. They're basically the same thing, except one has y equals, and it's a whole infinite number of points, and one has 0 equals, and then we're just looking for the x-intercepts. So one way that you could actually solve a quadratic equation of this form right here is you could graph the associated quadratic function and then find the x-intercepts. So if I said solve this quadratic equation right here, one way you could actually solve this is to say, alright, I'm going to change this into x squared minus 2x minus 3 equals y, which is a quadratic function now, right? It's exactly the same as this up here, isn't it? I could graph that, which would look like this parabola right here, and then, since I'm interested in when y equals 0, I'd be looking for the x-intercepts. And there's my x-intercepts right there. And that would be my answer to this right here. That's one way you could do it. The other way you could do it, and believe me, this will be the way you usually do this, is you could do it by factoring. So let's try that. Let's try factoring this quadratic equation right here. So this is a simple trinomial, and this is the thing we've already done before. If you factor this simple trinomial, you're going to get two binomials, still equal to 0, has to be x and x to get that x squared. Two numbers that multiply to 3 and subtract to 2. That's 3 and 1. Drag down the minus sign. A negative times a what equals that negative? A negative times a plus. So what we have found right here are two factors. These are factors right here. Yeah? And now I need to remind you of the zero product property, which I know I've mentioned before. I'm going to do it again right now. Basically, the zero product property comes into play when you have two things, or more than two, I suppose, but let's just stick with two. If you have two things that are multiplied, product, right, and you get 0. Okay, what do you know about the two things if they multiply to get 0? Well, if two things multiply and get 0, then, I guess I should say if a times b equals 0, then either a equals 0, or b equals 0, or both of them equal 0. You can put a equals b equals 0. In other words, they're equal to each other and they're both equal to 0. Right? That's the zero product property. Now, this only works with 0. If we had a times b equals 8, can you say anything about a or b? No, you can't say anything. A could be 2 and b could be 4. A could be 8 and b could be 1. A could be 0.5 and b could be 16. You don't know anything. In fact, the only thing you know is that neither one of them is 0, but that doesn't help us at all. So the zero product property only comes into play when the two things multiply to 0. Well, in this case, if we go back here now, we have two factors that multiply to 0. So either the first one, x minus 3, equals 0, or the second one, x plus 1, equals 0, or both of them equal 0. Now, what would make the first one equal 0? Very simple equation to answer here. We get x equals 3. To solve this one, subtract 1 from both sides, x equals negative 1. So we get the answers x equals 3, and x equals negative 1. Hey, take a look up here at what our x-intercepts are. X equals 3, there it is. X equals negative 1, there it is. So you can see that you could solve this in two ways. You could either graph and find the x-intercepts. It takes a little longer, I don't recommend it. Or you could factor to find the x-intercepts. And that seems like a better plan to me. So here's how to solve the quadratic equations by factoring. Set the equation equal to 0, right? You have to make sure it's equal to 0. If it's not equal to 0, you got to move some stuff around to make it equal to 0. Factor the non-zero side. Of course, you're not going to factor the side that has a 0 on it. You're going to factor the other side. I factored this side right here. Use the zero product property to solve each factor. That was this step. I set them both equal to 0. Both of the factors I set equal to 0. Reject extraneous roots. So you're going to get some answers sometimes that really aren't answers at all. This will usually happen when you have fractions. And number 5, check your solutions. So one thing here with this word roots, these answers that you get, for example right here, the 3 and the negative 1, these are called roots. They're also called solutions. And I think just a couple minutes ago I said that you could also call them, or I mentioned them as zeros. They're technically not zeros. What zeros are when you solve, I mean, we're really splitting hairs here, but if you solve a quadratic function, if you graph it, and you find the x-intercepts, like we did right here, we found the x-intercepts, then these x-intercepts are also called zeros. And that kind of makes sense, right? Because the reason it's called zeros is because the y value at that point is zeros. It's kind of like we put 0 into the y. So these two points here are called x-intercepts, or zeros. That's with a quadratic function. And with a quadratic equation, when you get your answers, they're called roots or solutions. Now, you're going to hear me sometimes call these zeros. I just mess it up sometimes. I'd probably even call these solutions sometimes. But if you want to be really, really, really accurate about it, zeros are x-intercepts, roots are solutions. Okay, let's try a few. Okay, first question. Remember, we have to set it equal to 0. So this isn't equal to 0. You need to move either both things here over to the right, or you need to move this 20 over to the left. Which one should we do? We should move the 20. Is it because there's only one thing on that side? No. It's because we want this leading coefficient. We want the x squared to have a positive coefficient. So we should leave that there and leave the negative 7x. But we should bring the 20 over. So it should be minus 20 equals 0. Okay, now we're ready to factor. Uh-oh, what kind of factoring? Bobby Bridge. So we're looking for two numbers that multiply to 60. 3 times 20 is 60. Remember, you need to be able to factor in this course. 3 times 20 is 60. We're looking for two numbers that multiply to 60 and subtract to 7. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, 7, 8, 9, 10. That's it. Which one of those subtract to 7? I believe it is this one right here, isn't it? So we're going to decompose that middle term. Keep the first one the same. We're going to put these numbers in. It's going to have to be minus 12x plus 5x to get the negative 7x, and then minus 20 equals 0. Pair them up. Greatest common factor of the first two is 3x. You're left with x minus 4. Greatest common factor here is 5. You're left with x minus 4. Great, it worked because we have the same thing in both, which is x minus 4. And then we have 3x plus 5 equals 0. Awesome. So now, zero product property. If this factor times this factor equals 0, then either the first factor equals 0 or the second factor equals 0. What would make this one equal 0? Well, if you add 4 to both sides, you'll get your answer. X equals 4. What would make this one equal 0? Two steps here. You got a minus 5 first. So you get 3x equals negative 5. Then you have to divide by 3. Let's keep it as a fraction. X equals negative 5 over 3. So we have our answers. X equals 4 and negative 5 over 3. We don't have to worry about extraneous roots because there's no fractions and there's no square root signs or anything. And you could check them if you want. I don't feel like it. Well, I'll check the first one just to show you that it works. Put 4 in here. 4 squared is 16, and 3 times 16 is 48. I'll just write that down, 48. 7 times 4 is 28, and 48 minus 28 is 20. So we know that one worked. I don't want to try the negative 5 over 3. It's going to be too much work, too much time. We don't have time for that. Alright, you do though. Do it on your own. So next one, 2x squared equals 4x. We want to make this equal to 0 again. So which one should you move? We want to keep that x squared positive. So don't move this over to the right. I mean, it'll still work, but you're making your life more difficult. Move the 4x over. And now it equals 0. People often get confused here. They don't know what kind of factoring this is. It's a binomial, but it's not a perfect square binomial. But what kind of factoring do you always need to try to do first? Greatest common factor. The greatest common factor here is 2x. And you're left with x minus 2. 2x times x is 2x squared. 2x times negative 2 is negative 4x. It's still equal to 0. Here's your factors. You have one factor here in brackets and another factor here in brackets. Yeah, you don't have to put in brackets, but I'll put it in brackets so you're clear. So in other words, either this first bracket equals 0. This is a zero product property, right? Either that first bracket equals 0, the first factor, or this x minus 2, the second factor, equals 0. Let's start with this one. What would make this one equal 0? Well, if you add 2 to both sides, you get x equals 2. What would make this one equal 0? This is 2 times x, so you have to divide by 2. Divide by 2. You get x equals 0 divided by 2 is 0. So there's our answers. The answers are 0 and 2. We could check both of these ones really fast. 0 squared is 0 times 2 is 0. 4 times 0 is 0. Yep, those both equal 0. Put 2 in here. 2 squared is 4 times 2 is 8, and 4 times 2 is 8. These both work. Okay, for this last question, I want to show you how you can solve quadratic equations by using a graphing calculator. This is something I didn't do with my pre-calculus class, so there you go, something you can teach them. So we're going to try to solve this equation right here. It's hard to read, but it says 2x squared minus x equals 3. And we said we always want to make our quadratic equations equal to 0. So I guess the easiest way to do that would be 2x squared minus x. Move the 3 over, it becomes minus 3 equals 0. Now, in order to do this, we want to think back to what we talked about earlier in this chapter. This section about this isn't a quadratic equation. What's the related quadratic function? And in order to get the function, we just change that 0 to a y, right? So you get y equals 2x squared minus x minus 3. And our strategy is going to be the following. We're going to enter this quadratic function into our graphing calculator. I'm going to show you how to do that. And then we'll graph it. Of course, what shape will it give? It'll give us the parabola. And then which point or points are we going to be most interested in? The x-intercepts, the zeros, right? We said that if find the x-intercepts, we found the solution to this quadratic equation. So let's do that. I don't think we've ever graphed quadratic equations on a graphing calculator yet, so I'll have to show you how to do that. So first thing I have to do is find my graphing calculator. Here it is. And you're going to hit this button up here. It says y equals. Unfortunately, the buttons are a little bit low on my computer here, so it looks like I'm pushing just below the y, but I actually pushed the y there. Okay, so it says y1 equals, and this is where I'm going to type this in, to the x is this button here, x, squared I hit here for squared. Again, I'm pushing below all my buttons, right? I'm sorry about that. Minus x, so I go back up here and push that x button again, minus 3. And there you go, I've entered it in right there. y1, or just y, equals 2x squared minus x minus 3. I want to graph that. So I go over here to graph, and I hit it, and I should get a graph. Great. And what I want is I want to find the x-intercepts here. Now here, you might be able just to look at them and tell. Let's zoom in first. Why not? Just so I get a better look at it. So I'm going to zoom in on number 2 here, and then I just push around where I want to zoom in, and that should work once I hit enter. Great. So you can get a pretty good sense of what the x-intercepts are right now. But let's say you want exact. I don't know exactly what this one is over here. So what you can do to get exact is you're going to use that calculate button up there. So you're going to put second and then trace, because now I've got calculate. And what I want to calculate is the 0, right? We said another word for x-intercept is 0. So I put number 2 for 0, and it says left bound. Let's start with this point right here. You can start with either one, but I'll start with this one here. And we want to go to the left of that point. Well, to the left of that is it's actually up here, isn't it? All these points are to the left of the x-intercept. So I should see something blinking. I don't actually see it right now. But when I push, I should see a blinking. Here it comes, I think. Yeah, see that X, that blinking X? I'm moving that blinking X so it's on the left side. So, maybe around there. That's definitely on the left-hand side of this point right here. It's just a little bit to the left. And being left means it also has to be up there. So I hit enter. And now it should say right bound. So I'm going to move that blinking thing so it goes to the other side. So maybe, I don't know, around there. And I hit enter. And then it says guess. So you're going to put it as close as you can to the actual. You find you actually don't need to do that, but I'll do it. So that looks pretty well exactly where the x-intercept is, and hit enter, and it tells me the 0 is at x equals -1 and y equals 0. In other words, y equals 0 at the x-intercept, and the x-intercept is -1. So I got one of my answers. One of my answers is x equals -1. Okay, let's go back and find the other one. So to find the other one, you have to start over again. You again have to hit calculate. So I go second, calculate, come on, and I want the 0, which is number 2. And again, I want to go to the left of this point this time when I'm working on this point. So if I go to the left of this point, that's over here, I'd have to do these points down there, right? These are all to the left of that point. So I got to move this blinking thing all the way over here by hitting the right arrow. It's going to disappear for a while, but don't panic. It's just going down to the vertex. Keep pushing it, and eventually it's going to start climbing its way. I know I can't see it right now. Come on. Come on, there it is. Okay, so maybe I'll stop around there. That's the left-hand side. Now it says right bound, so I move it up to the other side, so somewhere up there. Hit enter again, and now I want to do my best guess, so I'll move it back down to about there. That's a pretty good guess. And hit enter, and it'll tell me. And what it tells me is, again, y equals 0. It's perfect, because that's where I get x-intercepts. And it says the x-intercept is at 1.5. So my other x-intercept is 1.5. There's my answers. X equals -1, x equals 1.5. Remember, you didn't have to do that. You could have solved this by factoring. Should we do that really, really fast? What the heck? I'll do it really fast. This is Bobby Bridge. Two numbers that multiply to 6 and subtract to 1. So it's 3 and 2. So 2x squared minus 3x plus 2x minus 3. Pair them up. Take out an x, so you get 2x minus 3. Take out a greatest common factor is just 1. And you still have 2x minus 3. 2x minus 3 is in both of them. 2x minus 3, and then x plus 1. And you know what I've forgotten to put in both these? This equals 0 and this equals 0, so this still equals 0. So either 2x minus 3 equals 0 or x plus 1 equals 0. This is easy to solve. Just move the plus 1 over, it becomes minus 1, so you get x equals negative 1. For this one, add 3 to both sides. You get 2x equals 3, and then divide by 2, so you get x equals 3 over 2. Negative 1, 3 over 2. Negative 1, 1.5. What's 3.2 as a decimal? 1.5. It worked. Okay, so there you go. You have 3 ways, I suppose, to solve quadratic equations. One's by graphing by hand. You'll probably never do that. The other one's by graphing using a graphing calculator. You might do that sometimes. And the best way, I think, for now is factoring. If you can solve it by factoring, it's the fastest way to do it. Okay, have a good day.